Okay, this is going to be a supplement to that other function notation introduction. So this is the college algebra intro to functions. Additions. So some things that weren't covered in the intermediate algebra video. So one of the things you're going to look at is how to tell if an equation represents a function. And though it's not always stated a function of y of x. So how do we tell? What you do is you solve for y. If you get one answer, then it is a function. If you get more than one answer, it's not. One of the defining feature of what a function is that for each x value, you only get one y value, one answer. So when we're trying to say, what's the answer for y, we should only be getting one answer for that. So say, is it a function? We'll look at a couple different problems to determine if it is a function. So say 2x minus 3y equals 8. Is that a function? And what I do is I'm going to solve for y. Now that doesn't mean make x anything. That just means get the y by itself. This is like those linear or those literal equations we did earlier in the semester. Solve for a letter. So 2/3 x minus 8/3. This is a single answer for y. It has two parts, but if you plug a number in for x, you're only going to, and you do that calculation, you're only going to get one answer. So this is a function. Now let's say we had instead x minus 2y squared equals 1. So is this a function? I'm going to solve for y. So I'm going to subtract x from both sides. So negative 2y squared equals negative x plus 1. And divide everybody by negative 2. So y squared equals 1/2 x minus 1/2. And then I'm going to take the square root of both sides to get y by itself. And when I take the square root of both sides, that's going to give me y equals plus or minus. Because remember, anytime you start with an even power and you do an even root, you have to put plus or minus the square root of 1/2 x minus 1/2. Now, maybe I could fix that stuff inside to get some of that fractional stuff out of there. But the key thing here is that I got this plus or minus. I got two answers here. This is not a function. Typically, if you see that y has a power of 2 or 4 or 8 or 6 or any even number, you know it's not going to be a function. Likewise, if you had something like the absolute value of y equals x minus 3, I wanted to solve that. Remember, absolute value, you'd have to set up two problems to solve for the thing inside the absolute value. Negative x plus 3. Again, not a function. On the other hand, if you had y equals the absolute value of x minus 3, that is a function. Because when you plug a number in there for x, you're only going to get one answer when you calculate the absolute value. Now, if I was trying to figure out what x value would give me a certain outcome, I'd probably get two values for that. But that's not what we're talking about. We're not saying that two different x values can't give you the same answer. What we're saying is if you plug one x value in here, you can't get two answers for that, two results. So it's okay for x to be in the absolute value. It's not okay for y to be the absolute value. And if you're looking for, is it a function? So that's one thing that you didn't cover in intermediate. Another thing, I want to talk about the domain, finding the domain. Now in the intermediate, we talked about how to do it using the graph, but here we want to talk about how do I find the domain from the equation? How do I do it algebraically? And there's two issues we have to be worried about. Can't divide by 0. So any x value that would make you divide by 0 is out of the domain. And the second thing, well, when we're talking about domain, we want real numbers to go into the problem and for real numbers to go out. So that's why numbers that would make you divide by 0 are not allowed, because they don't give you real number answers. But you could also put real numbers in and get non-real numbers, imaginary numbers. And the way that happens is the inside of an even root. Well, if the inside of an even root is negative, that would be giving us non-real numbers, like give us i's. So the inside of an even root must be greater than or equal to 0. If that's not true, then the result would not be real. So we have to restrict it. So the first one's saying what's not allowed. The second one's saying what must be true. Those are two kind of different ways of approaching domain. So let's say we're set, find the domain. They gave us f of x equals 3x squared minus 4. So to find the domain here, I would start off by asking myself, would I divide by 0 here by putting a value in for x? And the answer is no, I wouldn't. Do I have an even root? Do I have an even root? No, I have an even power, but I don't have an even root. So neither of these rules apply to this problem. In that case, my domain is all real numbers. So one shorthand way of saying all real numbers is x is an element of the real numbers. What about if we had the function g of x equals 3 over x minus 4 plus 5 over x plus 2? Now I want to ask myself, are there any values of x that would make me divide by 0? Well, I'm dividing, so that's now suddenly relevant. And the answer is yes, there's two numbers. 4 would make me divide by 0, and -2 would make me divide by 0. So what I'm going to say is x cannot equal +4 or -2. And what I mean by that is x can be any number but those two. Now, you might see some people write the answer more like, you can go from -infinity to -2, but skip over it. And then you can go from just past -2 to 4, skip over 4, and then go 4 to infinity. And that would be saying what is allowed. Usually it's easier in this case just to say what's not allowed. Let's say we had f of x equals the square root of x minus 6. Well, now I'm not dividing, but I do have an even root. So I want to say this inside part, whatever it is, must be greater than or equal to 0. Now if I solve that for x, I add 6. X must be greater than or equal to 6. So that is my domain. X has to be greater than or equal to 6. As long as I'm picking numbers 6 or bigger, this is going to calculate to a real number. Now it might not be a pretty real number, it might not be a nice real number, but it'll be a real number. Okay, how about, we're still finding the domain. Say we had h of x was the 6th root of x squared minus k. All right, so again, I'm not dividing, but I have an even root. So that means this inside part has to be greater than or equal to 0. Has to be positive or 0. Can't be negative. Again, I'm not doing anything with this exponent or this root number. I'm just recognizing it's even. That's all I did. It's even. Okay, well then this inside part must be this. Now, this type of problem, what I'm going to do is, this is a nonlinear inequality. I need to find the critical values. So I'm going to solve x squared minus 10 equals 0. I'm going to add 10. X squared equals 10. Take the square root. My two critical values, because remember, plus or minus square root of 10. So I'm going to draw my number line, label negative square root of 10, label positive square root of 10. You can plug those in. I give you 10 minus 10 is 0, and that's okay because it's greater than or equal to 0. So those are going to be solid. Let's see. Negative square root of 9 is 3. Square root of 16 is 4. So this is 3 point something, right? And this is negative 3 point something. So how about we pick 0 in the middle, positive 4 over here, and negative 4 over here. And we put those in. So negative 4 squared, positive 16 minus 10. Is that greater than or equal to 0? Well, yeah, that's 6. So that area is going to work. Put 0 into this expression. 0 minus 10, is that greater than or equal? Nope, that doesn't work. So this worked, that didn't work. Again, put 4 in there, so you get 16 again. That's going to work, so this area is going to work. So my domain is from negative infinity to negative square root of 10, bracket, union, positive square root of 10 to positive infinity. That's my domain. So as long as I pick numbers in that domain, I'm okay. Right. And then the last thing that I wanted to cover that's not covered in intermediate is the 0 of a function. And what these are, x values that make the function equal 0. So let's say I have, so what's the 0 of f of x equals 2x minus 6? And the answer to that, what's my 0, is x equals 3. 3 is a 0. Now, why is 3 the 0? Well, if I were to plug 3 in for x, I would get 6 minus 6, which is 0. Anybody say, how'd you know that? Well, just experience with this type of problem, but the better question is, how would I do it if I didn't know it? And so the way we do that, so let's say we given a different problem, more complicated problem. Find the 0 of g of x equals 3x squared minus 5x minus 2. And I said, what is the 0 of that? Well, the way I'm going to figure that out, I can just look at it and know necessarily. What I'm going to do is I'm going to take this expression and I'm going to say, when I plug a number in there for x, I want the answer to be 0. So I'm going to solve this equation, this quadratic equation. And I don't know, maybe we'll use the quadratic formula. Negative 5 plus or minus square root of b squared minus 4 times my a value times my c all over 2 times my a value. Okay, and then let's work that out. 5 plus or minus, got a 6 down here. Inside here we have a 25 plus 6 and 4 make 24. So square root of 49. So 5 plus or minus 7 over 6. 12 over 6 or negative 2 over 6. So what are my zeros? Got more than one here. Positive 2 and negative 1/3. Those are my zeros. Now, what did I just find? I found numbers that if I were to plug them in here, I said, what's g of 2? I'll do 2. You can trust me on the negative 1/3. and I plug this into my problem. So 3 times 4 minus 10 minus 2, so 12 minus 12, 0. So that's what we're looking for. It's what number or numbers can be plugged in for x, and the result is 0. So if you put 2 in there, now I couldn't just look at this one and know that it was 2. I had to work it out and figure out, oh, 12 divided by 6, that's 2, and then negative 2 over 6, that's negative 1/3. And again, I could do that same exact thing with negative 1/3, and I would still get 0. You can double check that on your own. That's what you're looking for. So you're going to set it equal to 0. You're going to take the problem, set your expression equal to 0, and you're going to solve it. Maybe it's a quadratic. You use a quadratic formula. Maybe you can just, something like this. I could just say 2x minus 6 equals 0, add 6. 2x equals 6, divide by 2, and surprise, surprise, the answer is 3. That's my 0, and that's exactly what I said the 0 was. So, and we showed it, that we got an answer of 0 when you plug it in. So you're going to set that equal to 0, and you're going to work it out and solve it.